Okay, so that is the reflection that I end up getting. Once you know that deflection, we can go on to the other side. And I'm really not sure how much further I should go on this problem because I kind of want to go a little bit more in detail because I feel like if I just leave you here, most of you are not going to. Or there's going to be a lot of confusion about what you should do next. But if I go any further, there's a chance that you might not understand what's going on well enough, and you won't be able to do this yourself on an exam. So I'm going to try and leave as much of this. I'm going to try and explain things a little bit, give you some hints, but I won't be giving you any more. I won't be going over that equation, those equations again. Basically, look at the deflected shape on the left-hand side. It should look something like this. Where this is your hinge. We already established before that it goes up like that again, but we're not interested in the right-hand side. We're just interested in the left-hand side of the hinge. I now know this length. This length here is delta H. I measured this. That's what I did in the first part of this video. Or that's what I did in the last video. In order for me to find the angle here, I need to know the angle somewhere else. I can get the angle here fairly easily. Right, this angle is theta A. This length is THA. Therefore, theta A will be equal to, and this here is, what is this length? That is 3L. Theta A will be equal to delta H plus THA all on 3L. That is how I get that angle there. Once I have that angle, I can get this is theta hinge on the left. Theta hinge on the left is equal to theta A plus delta theta. Recall that delta theta is equal to the integral, is equal to the area underneath my moment equation from A to B divided by EI. That is delta theta. With these two, I can get delta theta at the hinge. That is the second part. The last thing I need is the deflection under the point load. The point load is here. This is 2L, this is L. With theta A, I can now get this height, right? This height is, let's say that this is Z. Z is equal to 2L times theta A. I can get this height. This height is equal to T underneath the point load with respect to A. And therefore, the delta P, deflection underneath the point load, is equal to Z minus TPA. Okay, so I think that is, I guess I just basically did the problem for you guys, but that is basically all the information you need. but make sure you're able to derive this kind of information on your own. Always think back to where do I know the points. I know the deflections. I know the deflections at these 2 points. Therefore, I can get the angle at one of these points, or both of these points actually. I now know with one of these angles, I can get the deflection at the hinge. With the deflection at the hinge, I can get the angle at A. With the angle at A, I can get the deflection anywhere else in here. Once I know the 2 of these rotations, theta A and theta C, I can get the deflections anywhere pretty much. Yeah, I think that's pretty much it for this problem. We're going to go into problem number 2 next.